Section 5.2, right triangle trigonometry. So the first thing we're going to do is review our our trig ratios. So we know that we have opposite, adjacent, and a hypotenuse side. So if you remember from geometry SOHCAHTOA, then you know that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and I'm just abbreviating, and then tangent is opposite over adjacent. Now, cosecant, which is the symbol right underneath sine, so cosecant, and if we look a little bit below, is 1 over sine. So because of that, we now have the hypotenuse over the opposite. Since cosine, since 1 over cosine is secant, then secant is hypotenuse over adjacent. And cotangent is 1 over tangent, so we have adjacent over opposite. Now, when you do these, we're going to evaluate down here at the bottom, and when you do these, make sure your calculator is in degree mode. If you don't know where that is, you hit mode, and then you go down where it says radian and degree, and you need to be in degree mode. Okay, so the cosecant of 40 degrees in your calculator, you're literally going to do 1 divided by sine of 40. And hit enter, and you get about 1.556. So secant of 175 degrees would be 1 over cosine of 175, which is negative 1.004. And then when you do cotangent 1 over tangent of 180 degrees, you actually get an error, and this is undefined because when you do tangent of 180, you get 0, which is 0 over 1. And then if you did 1 over tangent, you would get 1 over 0, and 0 can't be in the denominator. So that's why it's undefined. Okay, so using these 6 trig ratios, we are going to work with this triangle below. It's a right triangle, and it's all going to be based off of this degree down here as it's noted. So sine of the angle is going to be 20 over 25 because you do opposite. So opposite of this angle is 20, and then the hypotenuse is 25. And then you simplify, so you get 4/5. Cosine is adjacent, which is 15. So you have 15 over the hypotenuse, which is 25. So you have 3/5. And then tangent is opposite over adjacent, which is 20 over 15, which gives you 4/3. So now if we went and we did 1 over sine, we would say 5/4. 1 over cosine is 5/3. And then 1 over tangent is 3/5. Oh, I'm sorry, 3/4. Okay, so now we're going to create a triangle and then answer all of these trig functions, and we're going to do it for 2 angles, A and B. So your first step is to sketch the triangle. And if you need to write down these steps, go ahead and do that, but I need to save some room. So step number 1, sketch the triangle. So here's my triangle that they gave me. Okay, so it's a right triangle, and this angle is actually C because they said C is 90 degrees. A is 15 and B is 18. So let's just say A is down here, so we'll say A equals 15. And we'll say B over here equals 18. Okay, so now what we don't know is, we don't know angle B, which is down here. It's opposite of the side B. We don't know angle A, and we don't know side C. So our second step is to find the unknown side. So we have two sides, we need to find the unknown side. So we're gonna find C, and the way we do this is Pythagorean's theorem. So C equals 18 squared plus 15 squared, and this equals the square root, C equals the square root of, so this equals the square root of 549. We do need to simplify this, so you're looking for a perfect square. That's a factor of 549, which in this case is 9 times 61. So the 9 can come out, and it becomes a 3. So we're left with 61 underneath the radical. Okay, so that's what C equals. 3 root 61. And you always work with exact values. Okay, so your third and final step is to calculate all of these ratios that you see over here on the right-hand side. So sine, we'll do sine first. So sine of A, this is A right here. So sine of A is opposite over hypotenuse. And if we do that, we get 15 over 3 square root of 61. Now, you are not allowed to have radicals left in the denominator, so we have to rationalize it. And you always multiply the top and the bottom by the radical that is in the denominator, because the square root of 61 times the square root of 61 is essentially like saying the square root of 61 squared, and the square root and square cancel each other out. So that means left on the bottom, you're going to have 61, and then 3 over 15 you just simplify, which is 5. And then again, you multiplied by that 61. So this is your final answer, sine of A. So cosine of A is adjacent over hypotenuse. So this is going to be 18 over 3 root 61. And again, we're going to rationalize again, but I can do it now that I've done it before, and I know that 61 is going to be left up top, on the bottom. Root 61 is up top, and then 18 over 3 simplifies to 6. Tangent of A is opposite over adjacent, which is 15 over 18, which simplifies to 5 over 6. All right, so now we're going to go back with all the angle A trig functions, and we're going to do the reciprocal of these. So cotangent is 6 over 5. Now cosecant is 1 over sine. Now what we have to remember is we rationalize sine, so I don't want to use this final answer and flip it, because then I have to rationalize it again. I'm going to actually use the very beginning ratio we had and then flip that. So that gives me square root of 61 over, and then that would be 3 over 15 now, so 5 is in the denominator. So it's just much easier if you think about using the original instead of the rationalized version, because I'm going to have to do that again here. With secant, so it's 1 over cosine, so it's going to be square root of 61 over 6 this time. Okay, so now what we're going to do is switch angles. Now we're dealing with angle B. So all of that again with angle B. So sine of angle B is going to end up being 6 root 61 over 61. Cosine 5 root 61 over 61. Let me use a different color so we can keep them separated. Sorry about that. 5 root 61 over 61. And then tangent is going to be 6 over 5. Cotangent, 5 over 6. Cosecant, which is 1 over sine. And again, we're going to use our original. Which was before this step, which was 6 root 61. So we're going to have root 61 over 6. And then again for the other one, we had 5 over root 61, so we're going to have root 61 over 5. Okay, so now they give us sine of theta, which is 4 over 7. So that's actually, it's a different way of telling us some sides instead of just giving it to us right away. So we're going to use this, and we're going to do the exact same thing we just did before. Step 1 is to sketch your triangle. So I have my right triangle. So sine, so if this is theta, because we have to label where theta is. If this is theta, the unknown angle, then sine of that is opposite, which goes right here, over hypotenuse, which is 7. So the first step is to find the missing side. And we'll call it b. So b equals the square root of 7 squared minus 4 squared. Now we're subtracting here because we're solving for b and not the hypotenuse, and the one before we added because we were finding c. So if you can't skip ahead like this and you have to do a squared plus b squared equals c squared at the very beginning, then go ahead and do that so you don't get confused. So b is going to equal the square root of 33. Okay, and I'm actually going to erase my work now because I need some more room. Okay, so now let's find cosine theta, which is adjacent over hypotenuse, which is root 33 over 7. Sine of theta is opposite over adjacent. I'm sorry, opposite over hypotenuse. Which, oh, I'm sorry, we don't need to do this. We were already given this. This is 4/7, so we could write it, but we don't need to calculate it. And then tangent of theta is now opposite over adjacent, which is 4 over root 33. So if we multiplied it by root 33 over root 33, we get 4 times root 33 over 33. Okay, so let's do the secant, which is 1 over sine. I'm sorry, 1 over cosine. So this is going to give us 7 over root 33. But when we rationalize it, we're going to be left with 7 times root 33 over 33. So then the cosecant of theta is 7 over 4. And then our cotangent of theta is the original, which is root 33 over 4. Okay, so when you're asked to solve a right triangle, pretty much all this means is find all the angles and all the sides that are not given. So I'm going to draw a triangle based off of what is given. Okay, we know what do we know? We know that we have an angle of 41 degrees, and this is angle E, so this is length E. We know we have a side of 20, which is side F, so this is angle F. And then we know that this is D is 90 degrees, so D is a side we don't know. Okay, so the first thing we need to do that's simple is to find F. So to find angle F, since we have two angles and we need the third, so angle F is going to come from 180 minus 90 minus 41, which is 49 degrees. So that's our angle. Okay, so let's find E, side E. To find E, you can use several trig functions now. Since, I wrote 41, I meant 49. It should be a 9. Okay, so you can use several trig functions now. If you're going to start with angle F, it's going to be different than if you started with angle 41. All you have to know is that E needs to be part of your trig function. So I'm going to use angle E. So I'm going to use the 41 and say tangent of 41. Okay, so meaning if I look at 41 and I involve E, it's opposite over the other side I have, which is adjacent, which is the 20. So I have to go opposite E and then adjacent, which is 20. And I had to do that one because I need to involve the 20. So in your calculator, since it's in degree mode, you're going to do tangent of 41, and then to get E by itself, we're going to multiply it by 20. So E should equal about 17.386. And then the last side, again, you could switch it up. You could use tangent. With 49, you could use 41 and use opposite over adjacent. Now that we have it, you can use sine. I'm sorry, not opposite over adjacent, opposite over hypotenuse, because we need to find D. Or you could simply use the Pythagorean theorem. So you have a bunch of choices here. All you need is to have D part of it. So I'm going to use Pythagorean theorem, and it's 20 squared plus 17.386 squared. And when I do the square root, I get about 26.5 for my side. So because I have all the sides and all the angles, I solved this right triangle.